And with that, that is it for me. It is my pleasure to introduce you to my colleague, Jan Chasin, who is a solution engineer at JFrog and who is your presenter for today.
Okay, thank you, Nera. So yes, so thank you. Welcome actually to this webinar, and thank you for joining us. So today, okay, so we'll see actually how you could use the JFrog platform to implement a CI/CD pipeline. Okay, to deploy your application to Kubernetes. So yeah, briefly, a few words on me. So I'm Jan Chasin, solution engineer at JFrog. So it's been now I've been here for 3 years, and my job is actually to perform these kind of events, so webinars, to write blog posts, white papers regarding our products, and to help our customers or prospects, okay, to integrate our product in their delivery process, CI/CD pipeline. And okay, so this is the agenda for today. I will start basically to explain what is the JFrog platform, okay, which products or services are available within this platform, and I will drill down into almost each service of the platform. Okay, so I will start with then with Artifactory, the binary manager. Then the third bullet point here is the JFrog X-Ray, the security solution. Basically, it will scan the binaries which are stored into Artifactory. And I will finish actually by doing a presentation on JFrog Pipelines, which is the CI/CD server from JFrog. Okay, so now let's dive into the first section, okay, the JFrog platform overview. So I will describe the platform by actually first, briefly showing it's a standard delivery process, okay, where you will start actually by having a VCS, okay, version control system, where you will store your code into different source repositories. Okay, it could be like Bitbucket, GitHub, GitLab, SVN, using SVN. During your process, where you would mainly rely on build or package tools to perform the build. Okay, so here I added some icons to represent the Gradle client, the Maven client, the Python pip command, npm client for JavaScript project. The small square in blue with two rows, I would say, is the NuGet client for .NET developers. The last one is Conan, for the C++ community. If you're using, you can use Conan as a package or build tool. Okay. So during your process, so you will be building and relying on these tools, build or package tools. Some point where to perform continuous integration, you will rely on a CI server, okay, to perform your build regularly and test. Also, in your process, especially if you're doing if you're planning to use Kubernetes, you would use also a binary manager. First, to store your own applications. Could be here a Java component, an npm package, or an exec file. Could be stored into you would store it into or publish it to a binary manager. We'll see also that you can use a binary manager to use it as a proxy, to download dependencies from external repositories. Then, once you've built and run some tests, or unit tests, or whatever test, could be code scanning or quality code scanning. You would like then, to deploy what you have onto a specific environment, a runtime environment. So you would rely on a tool to perform the continuous deployment. And then we have a runtime environment. So here in this webinar, we'll be using a Kubernetes cluster. Okay. Also, in this, you may have I would say in your use case, a distribution process, where you would like to, I would say, once it's been deployed and tested in your own environment, you would like to distribute your product to your customers. Okay, so this is, I would say, a standard delivery process. And okay, so now what is exactly the JFrog platform? So the JFrog platform is actually composed of different services or products. Okay, so the first one is actually Artifactory, which is the core product, okay, and it's a binary manager. You will then also have, okay, during the analysis test phase, you have X-ray, which will be here to scan, okay, what the binaries that you would store within Artifactory. And then for the CI and CD phase, you would use, okay, JFrog pipelines. Okay. We also have actually in the platform another product called JFrog Distribution to really cover this distribution process. Okay, so don't get confused when I say, let's say, continuous deployment or deployment and distribution process. It's two different, I would say, steps or phases. Okay, so the deployment is really when you would like to install or deploy an application to a runtime environment. Okay, so you fetch it from Artifactory and deploy it here onto your Kubernetes cluster. The distribution process is more actually to ship a binary close to a consumer. Okay, so you won't deploy or install your binary. You will actually here. The concept is really to create a network of Artifactory instances. You will have a source Artifactory. Okay, let's say you would like to distribute a binary to Asia, okay, to Japan. So you have your source Artifactory, let's say in Europe, and then the distribution process would be to send, okay, a binary from a source Artifactory in Europe to another Artifactory in Japan. Okay, so this is the distribution process. So we don't get confused by these two. But anyway, so today it's focused on deployment to Kubernetes Kubernetes clusters. So I won't actually go over the distribution process. It would be another webinar. But here, so we mainly cover, okay, these three components or three services: Artifactory, the binary manager; X-ray, the scanning solution to scan binaries; and JFrog pipelines to cover CI and CD processes. Okay, so let's actually start with Artifactory, which is the binary manager. It's a universal, actually, binary manager because you will be able to centralize all your binaries into Artifactory. Okay, as you can see on this slide, we are covering different package types. Okay, so here in our use case, we have Helm. Okay, we'll be using Helm and charts, Docker images. You can see, okay, on the right. Upright. You can store also your Java applications via, I would say, Maven or Gradle repositories. NPM, okay, you can also store your NPM packages. You get any kind of packages that you are using, you will be able to store them into Artifactory. Okay, if you have exec file or I don't know, MS5, for instance, you can store them into generic repo. Okay. So when I will use the term binaries or packages, could be I would say a jar file, a WAR file, an exec, a dynamic or static library. It's up to you. Even a document. Okay, you can store your data test into a generic repo, for instance. Your reporting as well. You can store anything into Artifactory. So you will also use Artifactory as a single access point. Okay, so here, as I said, you can use it to centralize all your binaries from your organization. So here, let's take this example where you have, okay, you're performing a build. So you have two use cases for your binary manager. First, to store, I would say, your applications or your built binaries. Okay, so you can see your CI server will publish, okay, after the build, it will publish the result of the build, the binaries, to a local repository. Okay, so in Artifactory, you have the concept of repositories to store binaries. So a binary will be, or an artifact will be stored into a specific repo. So when you're publishing, when you would like to upload a binary to Artifactory, you will actually upload to a local repository. And obviously, then if you need to retrieve your binary to download it, you can also download your component from a local repo. You then have a second use case, actually to use your Artifactory as your binary manager, is to use it as a proxy, okay, to fetch external, I would say, dependencies. Okay, so when I say to fetch or download external dependencies, it means that you can actually rely on Artifactory to pull, let's say, dependency that you would get from JCenter if you're doing Java, I would say Java project, npm registry, npm JS. If you're a JavaScript developer, pypy.org, if you're a Python developer. So instead of directly reaching out to this external repo, you will actually hit on Artifactory. And Artifactory will first check if the binary, if this dependency exists, okay, if it has it. If it's not, it will fetch it for you, and it will store it. It will proxy and cache the binary. So then, if you have another a developer or another bit which is requesting the same binary or the same dependency, it will go to Artifactory, and it will get it. So it will be much more faster actually, to retrieve it and to speed up the build process when fetching dependencies. Okay, so in this context, you will have actually in this slide, you have two repositories, a local repository to be able to push to and also to download from, and a remote repository where you will actually only download component and cache them. So two repositories, two URLs, one to download, one to upload. Not super convenient, you will tell me. So that's why you have the concept of virtual repository, which is a way to aggregate multiple repositories under a single URL. So here, your build, or your build will actually only needs one URL to be able to download and to upload. Okay, so it's going to be much more easier to handle, especially for the consumer side. And yeah, so if you want to have a real life example, so this is for Docker. Okay, so here I will use, for instance, one virtual repository which will aggregate one Docker remote repository which is pointing to Docker Hub. Okay, and on this slide I have not one but two local repositories. One I would say dedicated for deployment to my SIT environment. Yes, it's a system integration test. And another one dedicated to deployment to my production environment, production Kubernetes cluster, our use case. And so on here, don't get confused as well. So the concept of repository doesn't, I would say, imply, doesn't restrict the access. Okay, so the repositories is a way to organize your binaries. Then in Artifactory, you have the concept of permissions, where you can really assign per user, service account, or per group what they can see or what action they can do. If they have the read permission, the upload permission. Okay, so this will be managed by the permission model. Meaning that here, if you're using, for instance, on Kubernetes, you have two different service accounts. One, a service account to deploy to your, I would say, to your SIT Kubernetes cluster. A second one to deploy to your production, I would say, environment. They can actually use the same URL here, the same, I would say, virtual repository, the app Docker virtual repository. But based on the permission that they will have, they will be able to see what they can see. Okay? So if you had, for the service account for, let's say, SIT, for the SIT, if you only give it the read permission on the app Docker SIT local, if it connects, if he connects to the virtual repo app Docker, he will only see, what's it in the SIT local repository. Okay, even though the virtual repo is aggregating several repositories, as he's got only the read access on the SIT local, he will only see this, only see the content of this repo. Okay, so really make sure that you understand that there is separation between repositories, and then you apply permissions to restrict the access to a virtual repo or a local or a remote. Okay. So that's why Artifactory can be used as a single access point for all your binaries. We will also see in Artifactory the concept of metadata, which is a really powerful, I would say, concept. that you can use. So basically, a metadata is a key value pair that you can apply to any binary or artifact within Artifactory. It will allow you to perform searches easily. So you don't need to know exactly the exact path, I would say, to locate the binary. You just need to specify the properties based on your own needs. It's a real way to, I would say, to automate your process. You can rely on properties to look for this artifact. In Artifactory, we also have the concept of AQL, Artifactory Query Language, which is some kind of SQL, but for Artifactory. And it's also a way, to enrich the data on your binaries. You don't need to have another document to explain specific features or characteristics on your binary. You can directly inject that as properties. Okay, don't worry. So maybe it's a bit vague, I would say, but I will show you that into the demo. That you have the concept of properties, managed by Artifactory, and also custom properties that you can apply by yourself, to implement your own process. So I will show you exactly how we are using this metadata during a build. So for this webinar, it's based on Kubernetes. So you can use Artifactory as your Kubernetes registry to store your Helm charts, to deploy them to your Kubernetes cluster. To store, when your Helm chart, you're referencing your Docker images, so you will be able to store them as well in Artifactory. Your Docker images is actually might be using, I would say your own packages, your own applications, and also OS packages such as Debian or PM and Alpine packages. So you will be able to have everything in one place. Okay, so now it's time for a demo. So we'll share my screen. All right. So I'm going to share my Artifactory, which should come in a minute. Okay. Hopefully you can see my screen. So this is Artifactory. Okay, the home, Artifactory, I should say the JFrog platform now. You can see the all the services on the left panel. Okay, you have Artifactory, JFrog distribution that I won't actually talk today about, JFrog pipelines and X-Ray. Okay, and you will need a specific subscription to unlock each product. So I talk about different repositories, and so I will actually demo what I've explained. Okay, on my slide. So in Artifactory, you have the concept of repositories. Okay, so we have different repositories here. One for Docker. Okay, you can see this is a virtual repo because it includes a local repository, or actually two local repositories, dev and SIT, and a remote. You have the same for Docker, for Helm. Sorry, switch actually. You have the same concept for, I would say, any kind of package type. Okay, for Helm, again, I've got a local, two locals, and one remote. It's up to you to decide how many local remotes you'd like to include, obviously, into virtual repositories. And you have, also the same concept for generic and NPM. Right. So if let's say I take, I will go into my local repository, I will see all my Helm charts that I'm storing, that I'm using, actually. I will switch, actually, to my Helm chart. So here you can see, when I click on this, the specific Helm chart, actually, I can also expand and see what's within my Helm chart, which is a table, basically. You can see the different YAML file. Okay, you can even actually look into the YAML file if you want to see it. You can see its content. And also all the YAML file. So here, you can see for each file you have a general tab with the size, the path, number of downloads, and etc. You have also a tab for here for the Helm repo to display, I would say, the content of the chart.yaml file. Okay, You can see for any artifact who can access it. Okay, users and groups. You have the different actions available. Same for groups, and in which I would say permission this repo is involved with two permission targets, which are actually relying on which are targeting this repo. Okay, so you also have I mentioned the properties, so you can really apply properties as you want. Here, these are actually properties extracted by Artifactory from the Helm chart. Okay, you have some metadata. So now, if I want to look for, I would say, a Helm chart, I can rely on these properties to look for it. Again, you can also add your own, I would say, your own metadata. Oops. If you want to add whatever you want, you can also add it. So that's why it's also good for automations. You can really create, update metadata. You have the same concept, okay? So we are still into the Kubernetes world. So you have the same concept for Docker images. Okay, we'll take this one. So this is an image. Okay, I've got also the tag. So on the latest tag, you can see all the layers. Okay. So here, actually, the layers are also tables. Same, okay, general tab, effective permissions. If I go to the properties here, actually, sorry, before I click. So I think I got some issues on the network, so bear with me. Okay. This is the property that I want to click on. Yeah, that's the demo effect. Just need to wait because. Okay, so whatever, I will just click here. If I want to see the properties, I should have to click on this. I think that's. Very sorry. Just need to click a bit. So here, okay, I'm clicking on the manifest.json for a Docker image, and if I click on the properties, yes, now you can see it. Okay, you can see the properties extracted from the Docker image are applied to the manifest.json. Okay, and you have the same tabs. Now, so I will show you a last example. So here, this is I'll show you the Helm chart, the Docker image, and if I take, let's say, okay, a generic repo, where I can store anything I want. Okay, I will take a binary. Actually, this is a Go application, and you can see here I have specific properties related to the build itself. So the idea, in Artifactory is really to understand which binary are used and why you have them into Artifactory. So I know that for this binary, which is an exec, okay, it was generated by this specific job name or build name, this specific run at this specific time. And you have as well on Artifactory the build tab, where I can see that this binary was actually produced by a specific job. It's not used, it's not a dependency of another build. So if I click on this build, I'm actually lead to the build or build info section. So in Artifactory, you have the concept of build info, where it's a bit of material, it's a BOM, where you can see what has been I would say generated by your build and consumed. So here, for instance, this is a Go app, a Go binary, which relied on these 3 Go packages, Go modules. Okay, so you can also, so the build info is actually generated on the CI side via the Artifactory CI plugins for Jenkins or Azure DevOps, TeamCD. You can also use the JFrog CLI. For this one, I use JFrog pipelines, which is behind the scene using the JFrog CLI. Okay, so in the build info, you have the notion of what has been built and the notion of dependencies. Okay, you can also capture the environment variable during your build. okay, from your Linux or Windows station. I will come. You can also see the X-ray. I will come to these issues. You can also capture, okay, I would say the git commit message from. You can also extract the Jira, your Jira tickets from the git commit message. You also have, okay, in Artifactory, it's also possible to perform, okay, a promotion. So here you will be able to move. A promotion is to move a binary from a source repo to a target repo. Okay. So this is what you can get from Artifactory. I will switch back to my slide. Okay. So basically, what I've shown you is that you can aggregate everything, all the binaries into your Artifactory. It's going to be a single source of truth for your binaries. Okay, using remote, you'll be able to rely entirely on Artifactory. And with the permission model, you can really restrict the access to whoever you would like to. And okay, as now you have all your binaries into Artifactory, you would like actually to get some insight on these binaries because you would actually fetch them from the internet or from external repositories. Okay, so that's why we have JFrog X-ray. So with X-ray, okay, the goal of X-ray is really to scan what's within Artifactory in order to detect vulnerabilities onto your packages and to also detect the licenses used by these packages. Okay, so X-ray will perform, I would say, a recursive and continuous scanning. Recursive basically meaning that it will, let's say if you'd like to scan a Docker image, it will look for, it will open each Docker layer and look for any subcomponent that it will be able to find. RPM packages, Alpine packages, Debian packages, Java component, NPM. So you can see actually the whole list on the right, okay, which component can be detected by X-ray in a recursive way. And continuous scanning means that actually you don't need to actually trigger a scan each time that you're publishing or downloading, I would say, a dependency from the remote. Okay, so the scan is triggered on events. If you have a new vulnerability which is added to the X-ray vulnerability database, a scan will run to make sure that what has been actually scanned before is still the same. Second event is when you're actually uploading a new component to Artifactory, or when you're downloading new dependencies from external repositories via remote. Okay, so it's a recursive and continuous scanning. We will see that we can also actually also integrate an extra scan during your CI/CD pipeline, and you can rely on policies to warn you and to perform post actions when X-ray detects a vulnerability or a non-compliant license. Okay, so I will now switch to X-ray. I spend more time on Artifactory, so now I will jump to my Artifactory, my JFrog platform, I should say. Yes, taking a bit time to share. Okay, so I will now show you exactly an X-ray scan. So you can have X-ray scans at different levels, at two levels actually, at the package level or binary level, and at the build info level. So I will show you one actually for at the package level for a Docker image. Yes, I will go to the view. Sorry. It's a bit slow today. So we'll take this one. Okay, so you can see here on the package view, so I looked for this JFrog Docker image. You can see it's been scanned by X-ray, that it's been downloaded. I have 9 tags, 9 versions, and downloaded 60 times. If I go into this Docker image, I can see that it's been scanned by X-ray. So all my tags were scanned. I can have this graph or trends. Okay, for each tag, I can see how many, I would say, violations were raised or detected per tag. Okay. And if I drill down into an image, I will be able to see this one. the list of vulnerabilities. So here I'm at the package level, or the package in my Docker image. Okay. I've got a violations tab. Okay, I will come to it just after. I've got different tabs actually: violations, security, and license. So there I will explain what is the difference between the vulnerability and the violation. Just after that, I explain you. Okay, I show you the different tabs. So here I've got 204 vulnerabilities detected in my Docker image on different components. Okay, so here mainly it's on Debian packages. Oh yeah, which are in my Docker layers. I can see that for specific package, it's we also extra displays the fixed version to BAM2 if you need to get rid of this vulnerability. It's a high one, so if I click on this one, you will be able to have some information regarding this vulnerability. Okay, the CV, the identifier of the vulnerability, the CVE. It's a high vulnerability, a small summary. Okay, and actually the impact of these Debian packages infected. Okay, so this Debian package occurred is in this specific layer, which is used in this by this image. Okay, so you can really you also have the notion of license, so detect the licenses into different packages. Okay, here in the jar file, in the Debian package, and so on. So you can see I've got a 7 page. Okay, when it cannot actually detect a license, you can still apply it manually. So you have a list of pre-configured licenses that you can apply. You can also actually inject your own or your custom license. And here, so on this tab, it's pretty interesting to see actually what does this recursive system. Okay, so here it's a Docker image. I've got different layers, and for each layer, Xray managed to detect specific packages, Debian packages, and then it can tell me which one are infected. So here I've got Debian packages, and here maybe all jar files. Okay, so we have here. So I explained the violation concept. So here a violation is actually triggered by either the detection of a vulnerability or the detection of a non-compliant license. Okay, so I will explain how you can implement this. Basically, a violation is triggered by a combination of a policy, where you define when to raise the violation and what to do, and a watch. Okay, so these two concepts are here. But just before drilling down into this one, I told you actually that you can have Xray scan at 2 levels. Here, the package level. If you also have a scan at the the build level. Okay, if I take let's take a Python one. So here actually I produced a Python build info using the JFrog CLI, and I publish it to Artifactory. Okay. I've got actually one generated package, Python package, and I used all these Python packages during my build. So what I'm showing you for Python, you can do it for .NET with the NuGet client, with Maven, Gradle, even Docker build info you can do. And it's the same concept, at the build level. You can really see actually which vulnerabilities and licenses were used during your build for a specific build. Okay, so here you have I won't spend too much time because it's exactly the same information at the build level than at the package level. And here the Xray scan, as it's set on the build, it will scan all the binaries which are listed into your build info, dependencies, and also generated artifacts. If I go to descendant, in my build info, I have my generated package and dependencies, and Xray scan them. And you also have the concept of violation. Now I will explain what is the violation. So in the concept of violation, you need to actually it's a combination between a policy and a watch. Okay, so first, what is a watch? A watch allows you actually to give a scope to your scan. So you can have, I would say, scans per project or team. That's why we'll create a watch. okay, on this specific project, let's say. What I will do is actually to say, I will say, I want a scan for my specific project. My project is actually using these three repositories and a build info. Okay, and so this is the scope of the scan. And then I will attach a policy to mention when to raise the violation, and based on this violation, which action I can trigger. Okay, so here, that's why you could put the policy section. And you have, okay, a bunch of policies. Well, you have to create them. Okay, so we have two types of policies, security and license policies. Basically, security policy means that when Extra detects a vulnerability on one of your on a specific package, it will raise the violation. License policy is to raise the violation when Extra detects a non-compliant license. And it's going to be up to you to define what is, okay, a non-compliant license via by using, I would say, a whitelisting or a blacklisting. So here it's only a whitelisting. And then so we'll actually, so you have, okay, the concept of rule within within a policy to define different actions. Okay, so I will actually jump to another policy. Let's say this one, the security policy. So here, okay, based on the criteria, on the severity level of the vulnerability, I will actually perform different actions. Okay, if it's let's say it's if it's only a high violation, yes, raised by the high vulnerability, I want to raise the violation and to fail a build. Okay, so yes, because you can also integrate, okay, an extra scan at build time as well. So basically, okay, you specify the criteria based on here on the CVSS score version 2, and you define the automatic actions to perform. If you'd like to trigger a webhook when Extra raise the violation, notify, okay, your team members. Okay, so the email address will be specified into the watch. Also the deployer. If in your watch you've included, okay, a repo, you can block the download. Okay, you don't want actually to let other consumers use this infected package. We skip this because it's for distribution, and you can also fail your build. Okay, so the idea is to say, when I'm pushing a new package to Artifactory, then I want actually during my CI to scan it, and if there is vulnerabilities or violation detected, I want to stop my pipeline. Okay, so this is what you can get with Extract, basically to detect vulnerabilities and non-compliant license. Okay, generate violation and then act on the result. So then, so now that I've actually talked about, okay, introducing an extra scan at CI during the CI/CD process, so then I will actually talk about JFrog pipeline. So now I'm back to my slide. That's a demo time. Sorry, switch on this. Okay, so regarding pipelines. So it's so pipeline, JFrog pipelines is the CID server, as I said before. So it's the pipeline as code. Okay, so to describe your pipeline, you would use a YAML file. And in your YAML file, you will actually chain steps, which are actions, and resources. Okay, so resource I will show you that on the demo. Resource can be a build info. Okay, it can be also a Git repo. It can be, you have different types of resources that you can use to actually create your pipeline. Okay, in JFrog pipelines, you also have the concept of native integrations. If you'd like, let's say, to trigger a build based on commits on your STM, okay, it is possible. You can integrate with other registries, with Jenkins. Actually, we have a way to link them, okay, via, I would say, webhooks, with Jira, if you'd like to fire or create Jira tickets. For this demo, so I will show you how to integrate with Kubernetes. But it's also possible, okay, with pipelines to deploy to component to VMs as well. And in pipelines, we also have the concept of security at different levels. Okay, here it's you can really define who can access this specific pipeline, these specific integrations. And I will show you that you can also perform extra scans within your pipeline, and also store some secrets in a vault in the cloud, like the one from AWS or Azure. Okay, so for this demo, basically, I will. This is what I'm going to do actually, is to kick off, I would say, my pipeline. Okay, my Go pipeline by doing a commit. So it will create my Go application. When it's going to be done, it will then fire or trigger the Docker pipeline to actually containerize my application, my Go application. And when it's done, it will deploy to my Kubernetes cluster. So again, back to my screen. Okay. So so on the left panel now I can switch to JFrog pipeline. So hopefully you can see my screen. Just want to make sure that you can see it. Okay, so here you can see now. I have to do it here. So on the left panel, on pipelines, I have different concepts. I have the concept of node pools. Basically, pipelines is you have what we call a control plane, where you have all the metrics, all your pipelines. Okay, so the control plane is basically this. And you have the concept of build nodes. So your build will be running onto Docker host. Okay, and you can I would say sort your Docker host into pools, into node pools. If you need to have specific builds on specific machines. You have also the pipeline sources. So the YAML file that I explained, which is describing your pipeline, is stored into a Git repo. Okay. You also have, as I explained, the concept of integrations. Okay, so here, basically, for my demo, I will rely on Artifactory to pull my Go modules and publish my Go application to Artifactory. So we'll rely on an Artifactory integration. Same for Docker. Okay, I will build and push my Docker image to Artifactory that I will use as my Docker registry. Okay, and for Kubernetes, I will use a Kubernetes integration. Okay, to be able to deploy to my Kubernetes cluster. So I will basically use a. You will have to upload into an integration your kube config. Okay, for Artifactory, you have to specify, I would say, the URL and your the API key of your user or service account. Okay, so I will now show you a pipeline. It's taking some time. So here I will use for the example, it's my Go application. So you can see you have different pipelines. Okay. We'll take this one. Okay, the backup Go pipeline. So here I'm switching to the control plane. A little bit. So maybe, So here you can see, by the way, the different pipelines that I will use are these ones. An identifier for them. So we use this pipeline to build my Go application, backup Docker pipeline to containerize my application, my Go application, and then deploy pipeline to deploy it to my Kubernetes cluster. I could have done everything into one pipeline, but for the sake of clarity, I use 3 different pipelines. Okay. So this is the pipeline. So I will maybe do it like this. You can see, my pipeline for the Go app pipeline. So it starts with a resource, which is actually an integration to my GitHub repo. Okay, you can see the different commit and who committed it. And then the goal is really when I'm doing a commit to fire the pipeline. So here I will actually run a Go build. When it's done, I will publish it to my Artifactory. So what I will publish is not only my binary, I'm going to publish a build info with my Go modules and my exec. I will run then, as soon as this is published, I will scan this build info to look for any vulnerabilities. And when it's done, okay, I want to promote this Go application to another repo. And then I will have, okay, a final resource, which is the promoted build info that I will use, okay, in another pipeline to fire it. So what I'm going to do actually is to fire it now, and then I will describe again the pipeline a bit more. Okay, so first, what I'm going to do, read something quickly. So I will update, okay, my Go app. We'll do again something very simple. I will just update the command. I will do, I don't know, reset. Okay, I'm going to commit my change and push it to, I said 40, to my GitHub repo. Okay, so this should fire then the pipeline. Okay, if I do a git log, oops, yeah, I've got, okay, the hashtag, you will see, so 3811. So if I switch back to my pipeline, you can see that it started processing to run the build. And the goal will be also, so at the end, to, okay, to deploy to my Kubernetes cluster. So here actually I have, let's say, oops, okay, sorry, code. Hopefully, it's going to be running. It's a bit slow on my side, so you can have, okay, a pod running for 3 hours. Okay, so my pipeline is running. All these steps that you're seeing are actually described into this YAML file. So here I'm by default, so I'm running my Go build into a Docker image. Okay, specific tag. So here I'm mounting actually the self-signed certificate, whatever. I've got the second step, which is my Go build, where I define that it needs, okay, it as an input resource my Git integration. I can set environment variables. I want also to be able to push and to pull to my Artifactory. I can also specify, I would say, shell or bash commands before the process run. Okay, on start, on success, on failure, you can really define what you can really customize your pipeline. And then I'm chaining, okay, my the steps. Okay, input steps is going to be the Go build. Okay, so it's running. And I've got, okay, my extra scan as well. So here you can see that everything passed. Should now, if I go to my Docker pipeline, it should be running. Okay, so it's a bit fast, but it went over the same pipeline. Okay, I'm creating, building, pushing my image to Artifactory. You can see, by the way, the log files here. Okay, so if I click on it, I will see exactly what's happening. Executing steps. So here I'm on this step actually. So it promoted my Docker image to another repo. Same, okay, if you go to here, you can see what happened into my scan. So it detected some unknown licenses, but I didn't want to fail my build. Okay. And okay, the entry of this pipeline is actually the promoted build info from my Go pipeline. And it also takes, okay, if I'm modifying my Docker file, I want also to fire this pipeline. And maybe it went a bit fast. If I go to my Kubernetes cluster, okay, so it was fired today. And so it went actually deployed my Helm chart with my Docker image. You can then run some tests if you like, okay, in parallel or not. And a regression test. So here it's a bash step. And to check if it's been running, hopefully get plugged. You can see it's been deployed to my Kubernetes cluster 62 seconds ago. So you can really, you know, the goal was really to show you that you can really, with the JFrog platform, you can really I would say, use or rely on the JFrog platform to trigger, I would say, a deployment to Kubernetes with a Git commit. Okay. If I go back here, you can see the hash, the last commit, and if you don't really believe me here, if I do a new scribe pod, we take this one. Okay, you will see that it's been pulling the image from Artifactory. Again, here actually I use the git commit hash in my tag. So this is my latest git commit. Okay, so this is the pipeline. So this is what you can implement with pipelines. Really funny stuff. And okay, so at the end, this is what I showed you. So you're on the slide now. I did the demo. And in conclusion, basically, this is, well, actually I already started the conclusion. But with the JFrog pipeline, you can really cover your entire CI/CD process, okay, from building using the CI using a JFrog pipeline, store all your artifacts and protect them, okay, restrict the access to them using Artifactory and its fine permission model. You can also scan, okay, add this security layer thanks to a JFrog Extra security solution, and also continue, okay, your pipeline by deploying to your Kubernetes or to your own or your VM, okay, or any kind of machine using pipeline. At the end, if you have a distribution process, you can also do it with JFrog distribution. So hopefully this is actually the end of my webinar. So Nera, maybe we can start to look at some questions, maybe. Because we have actually
we have a few questions, so I'll let you see which ones you would like to answer.
Yes, so I have one question, which is, can you comment more on the promotion process? If you already have a CI/CD such as Jenkins, how the artifact promoted? So, so here my demo was with JFrog pipelines, okay, but you can also do extra scans and trade billing info and billing info promotion with Jenkins. There is, okay, the Artifactory Jenkins plugin. For Azure DevOps, same, you have the Artifactory DevOps extension. For Bamboo as well, and if you're using GitLab CI or GitLab Actions, or Circle CI, for instance, you have the JFrog CLI, which is also covering generating bill info, scanning them, and promoting them. So I've got a lot of questions, so I'm trying to... So what is the effort to migrate in-house Docker registry to Artifactory? It's pretty straightforward, okay? Our documentation shows you exactly how you can do this. Basically, one of the requirements would be to have a reverse proxy, by the way, okay, in front of your Artifactory, to perform some URL rewritings between your Docker client and Artifactory. Also, do I need the JFrog platform as well? The JFrog, you know, if you're using Artifactory version 7, it's actually the JFrog platform. Okay. But if you'd like to unlock X-ray or pipelines or distribution, you have to switch or to subscribe to specific plan. Okay, with the Pro edition, you will unlock Docker registries and all the repositories. If you'd like to have X-ray, you have to to upgrade to a Pro X. So how easy is it to host Artifactory on Kubernetes? We have a Helm chart to deploy Artifactory on Kubernetes. If you're using OpenShift version 4, we also have an operator for Artifactory. Then, so can X-ray be extended to scan for restricted content and prevent upload to Artifactory? So yes, so you can restrict the content, the X-ray scan using watches. Okay, you can specify what it can scan. Actually, before you can do a scan, you need to register. Okay, you need to specify to index the repositories and builds which can be scanned by Extra. And can you prevent upload to Artifactory? I would say that to prevent upload to Artifactory, this would be done not by X-ray, but by the permission model. So let's say, and if, yeah, so the X-ray, you can only do block, you can just, I would say, block download with X-ray. And something that you should also understand that X-ray can scan only binaries which are in Artifactory. It's not possible to scan Docker image, which is another Docker registry. Okay, so I think that actually we are reaching the end. I covered the, well, we have more questions, but I won't have time to cover them. We'll cover them by email.
Correct. So I see a few more questions, but as Jan mentioned, we're also running out of time. So we'll make sure to get back to you by email. So thank you, Jan, for this great presentation. I just want to apologize for the small network issues we have. As you may know, this can happen during live demos sometimes. But we'll make sure to email you the recording of this webinar tomorrow. And thank you once again for joining us, and we hope to hear from you soon. Goodbye.
Thank you. Bye-bye.